talk about really looking at parts of an expression, specifically terms, and what we know about terms and what we can do when we identify terms that are alike. But before we do that, let's talk about our fair game review. Okay, so this is kind of like our warm-up. And one thing that we've been doing is identifying parts of an expression. So let's write that down. Identify the parts of each expression. Okay? That's what we're going to do. And we're going to kind of do a table. So what we're going to do is I want you to write down the word expression. Okay, and then draw a short line. I only went down 4 or 5. We may have to go down further, but we're going to start there. And then we're going to write 4x squared plus 7x minus x plus 3. Draw a line down. And then we're going to do 13y plus m plus 14. Okay. And then what I would do is I'd probably draw a line underneath here because this is what we're going to do, okay? So we are going to identify the terms, the coefficients, okay, the variables, and the constants. Okay, so I guess I have to go down one more line. There we go. And we're going to do that for each one of these groups. Now, when we're looking for terms, I want to be really clear with you. When we circle the terms, it makes more sense on what we have. So my very first term is 4x squared, so I'm going to circle that term. My second term is 7x, but I want to give you a little hint. When we circle the term, you want to circle the sign in front of the term so you know what it's telling it to do. It's telling it to add 7x, okay? My next term is x, but again, circle the term, circle the sign that goes with the term. Well, this tells me that, yeah, I have x, but really I need to subtract an x. And then the last thing is a 3. Now, notice that 4x squared doesn't have a plus or minus sign. When it doesn't have a plus or minus sign, we assume that it's positive, right? It's a plus sign, okay? So now let's list out the terms we have. And all we want to do is just list out the things that we put in the bubbles. So we put 4x squared. We put plus 7x, but when it's positive, we don't actually, or a plus, we don't write anything. So you can just write 7x. If you want, and I would recommend doing, is do you see how it says I'm going to subtract x? Okay, believe it or not, you're going to learn down the road in a couple weeks that this makes it negative. So go ahead and just copy that down like that, and if you only put x, you're okay. And then we have 3. All right, escape. Coefficients. Coefficients are the numbers that are attached to each variable. Remember, every variable has a coefficient. If you don't see one, it is one. So let me explain. The coefficient of x squared is 4. It tells me that I have 4x squared. Okay? It is a multiplier. It tells you how many of each variable I have. The coefficient of x is 7. It tells me I have 7 x's. It is a multiplier of 7. Okay, this is where it gets tricky. The coefficient of x. Do you see how you don't see one? But remember, the coefficient tells you how many of each variable you have. When you don't see one, it is one. It tells you I want to subtract 1 of the x. So I'm going to write minus 1. And you can sneak a little 1 in there if you want to. Now, in 6th grade, as long as you put a 1 here, just like I said, you don't have to put that negative there yet. But just know when you get to 7th grade, we have to make that transition. And then I have 3. Oh, just kidding. 3 is not a coefficient. I was just listing things. I hope you guys caught that. Okay, variables. The only variable that I see here is x. I see this x, I see this x, and I see this x. So the only letter I see is x. And the constant, the number that stands alone, stays constant no matter what, is 3. Okay? Let's do the same thing over here. my terms, circle the terms, circle the sign that goes with the term. Circle the terms, circle the sign that goes with the term. And when I say circle the sign that goes with the term, I want you to circle if it's got a plus sign that tells you you're adding it, and if it has a subtraction sign, it means you're subtracting it. And that's going to kind of drive our learning today. So our terms are 13y, m, okay, since it's adding m, we write m because I'm gaining an m, and 14. My coefficients are the numbers attached to the variable. If you don't see 1, it is 1. So we have the coefficient of y is 13. It means I have 13 y's. The coefficient of m is 1 because I have 1 m. And then that is it. The variables I see are y and m. And the number that stands alone, that stays constant no matter what, is 14. All right, so that is your fair game warm-up for the day. All right, hope you got that. We're moving ahead. Remember, you can always pause the video if you need to. All right, today is a pretty quick lesson on what we're going to do. So it has to do with these terms here, okay? So here we go. Our learning target for the day is we can identify, oops, that's an F, and combine like terms. Okay, I want you to underline like terms because that is the new thing that we have to figure out. So let's define what a like term is. Okay, now think about breaking this up. Like term. We know that terms are those individual pieces that are separated by plus or minus signs. Yeah, okay. So we know that that's what a term is. A like term is things that are like the same thing. So is this term like this term? Is this term like this term? I don't know. Let's try to figure out how we can identify that. So like terms are terms that have, okay, you got to pay really good attention to this, the exact same variable raised to the exact same power. Okay, so terms that have the exact same variable raised to the exact same power. So coming back up here, terms that have the exact same variable, well, these guys both have an x, but raised to the same power. Oh, well, this is raised to the second power and this one isn't. So these two are not like terms. Okay, so let's write down some examples of like terms. All right, the very first term that we should talk about is when we have a constant like 3. Okay, if I have the number 3, a term that's like 3 is another constant, another non-variable term. So maybe you were thinking the number 7. If you were reading my mind. Maybe you were thinking 10. Maybe you were thinking 53. Okay, believe it or not, this can include negative numbers. I know we don't know what to do with negative numbers yet, but believe it or not, negative 9 is a like term to 7. Because when I list out all my terms, this means to add 7, and this just means to subtract 9. If I'm looking at non-variable terms that are like 3, 7, 10, 53, and negative 9, I can think of fractions or mixed numbers like 5 and 2/3. I might have a fraction or a mixed number, but because I don't have a variable, it makes it alike all of these. Maybe I have a decimal or even a negative decimal. Okay, again, you don't have to know how to operate with the negative right now. Okay, maybe you have 59 over 100. Still all alike, all in the same category. Okay, Maybe you have a really big number like negative, or a really small number like 100, negative 105. All of these are alike because they are numbers without a variable. Okay? Let's look at this. If I gave you a term like x, okay? If I wanted another term that was like x, it means that it has to have an x in it and only an x in it. I can have numbers in it, but it has to have an x. For instance, 14x. 14x is like x because it has the same variable raised to the exact same power, okay? This term and this term are alike because this says I want 1x, this one says I want 14x's, okay? You can even have big numbers like 45x, okay? It really just matters about the variable, okay? Just like you could have negative numbers up here, you could have a negative x value, okay? You could have something like negative 3x. This just means I'm going to subtract 3x, right? And the variable stays the same. Okay? I could have a fraction, 4/5 x. It means I have just under 1x, and you could also have a decimal like 4 5/10 x or negative 6 7/10 x. Notice that what stays the same every single time is the variable. Okay? Now x is very different than x squared because remember our definition says it has to have the same variable, which this one does, but it also has to be raised to the same power, which this one is not. So x is not a like term to x squared. But 3x squared is like x squared. If I have 1x squared and I have 3x squares, I could combine those together and have 4x squareds. Okay? I could have negatives, negative 8x squared. Remember, this does say negative. We don't know what to do with negatives yet, but we do know that we're going to somehow subtract that, right? Okay? You could have a fraction, 7/10 x squared. Dun, dun, dun. Just 7/10 x squared. You could have a decimal, 14 9/10 x squared. You could have a negative mixed number or decimal. How about negative 5 1/6 x squared? Okay. It's okay if the numbers are negative or positive, and it's okay if they're fractions or decimals or whole numbers, or integers, I should say, because really, in order to determine if you're a like term, it only has to do with the variable and the power attached. Okay, now, something else that might come along is something like this. What happens if I have x, y? We haven't seen much of this before, but it's not just x, it's x times y. So the only other terms that are like xy are going to have both xy, and not x squared y and not xy squared, just x, just y. Okay? For instance, I could have 9xy. Do you see how xy and xy is the same? Then these are like terms. What about 12.1 xy? xy, xy, like terms. Okay, you could have negative 3 and, I don't know, 6/10 xy. Okay, hopefully with going through enough of these, you're saying that it doesn't really matter what numbers attached to it, because we're going to deal with that later. What matters is that we can see that the numbers that have the exact same variable raised to the exact same power are the numbers, or are the terms that are alike. Okay, so this kind of gives some examples of the like terms. And just to be very clear, I'm looking only here. So if you've got a highlighter, you might want to come through here and highlight the things that make these alike. These guys are alike because of this. Okay. Now, this row has like terms because of both the x and the y, just like this. Okay. So now what we're going to do is we're going to talk about a strategy on what to do with like terms. And remember our learning target says we can identify and combine like terms. So now let's talk about how I can combine like terms to help me simplify expressions. I'm going to go to a new page. Okay. So if you've got just a little bit of space here, I would go ahead and turn the page to, because we're going to create a little bit of a table. If you notice, your math teachers really like to create tables to help you organize information, because tables help us organize information. So here we go. This is our combining like terms strategy. Okay. Combining like terms strategy. So here we're going to put over here examples. And then I'm going to tell you that we're going to need less space over here. So I'm going to create a table like this. But notice I'm going to make this much bigger. Okay, and these are going to be our steps. Okay, all right, here we go. This is how you start to manipulate expressions. Okay, this is how you simplify expressions with variable terms. Okay, so this is very, very fun. So let's say I have a number 4, and I have a whole expression, plus 3x plus 6. Try to give yourself a little bit of space here, because we're going to kind of circle the terms and things like that. Plus 5x minus 2. That's right. We're going to start right away with subtraction, okay? Let me tell you our steps. Our very first step, you're going to circle the like terms, okay? Now, I'm going to do this with a couple different colors. So I'm going to start with a different color here, and I'm going to circle the like terms in different colors. So I've got a red, and what I'm going to do is I'm going to start with my very first term. This is a non-variable term. I'm going to go through and circle all other non-variable terms. And remember, circle the term, circle the sign that goes with the term. So my next non-variable term is 6. But remember, what am I doing with that 6? I'm adding it, so I have to put in that. 5x is not a like term, but 2 is. And what am I doing with 2? I'm subtracting it, so I'm going to write it like that. Okay? I'm going to use a different color. I'm going to use green. And I'm going to do the next term. The next term is 3x. Circle the term, circle the sign that goes with the term. So I'm going to circle plus 3x because it says I'm adding 3x. Okay. The only term left is 5x, which is alike because x there and x there. Circle the term, circle the sign that goes with the term. And now I can see that everything has been circled. Okay? And it's very important that you circle the sign that goes with the term, because when we start rearranging things, okay? All right, so here's what we're going to do. I'm going to start with my red terms, and I'm going to bring them down first next to each other. I'm going to start with 4, then I'm going to bring down, and I'm going to cross it out so I know I got it. Then I'm going to bring down plus 6. Now do you see why it's so important that we circled that plus? Then we're going to bring down subtract 2. Okay. Look at my green terms. I'm going to bring down plus 3x, and I'm going to bring down plus 5x. Okay. Now notice I have two different types of terms. I have non-variable terms and I have x variable terms. So I'm going to first just look at my color in red. In red, I have 4 plus 6, which is 10, minus 2, which is 8. Okay, now with just my green, notice that first I add 3x, then I add 5x. Well, if I have 3 x's and I have 5 x's, it means I have 8 total x's. So I'm going to add 8x. Okay, so let's keep going. So circle the terms, step 1. Step 2, what we did is we rewrite the like terms together. Okay, that's what we did. We rewrite the like terms together. Okay. We repeat steps 1 and 2 until we have to, but we really are just going to next simplify. So again, 3 steps. Circle the terms, rewrite the expression. Notice that we did that, and then we just had to simplify. We had nothing to substitute. So that's what we're going to do. Let's try it again. Let's try another example. Okay, you guys ready? So let's pull this down here. Okay. For this one, we are going to do 3y plus 6x minus 2y plus 7 minus x, yes, math expressions do get this long, plus 4x. And we're going to follow our 3 steps, okay? So I always start with this very first term, and that's the first one that I circle. So I'm going to look for all other terms when I circle like terms that are exactly like 3y. Well, when I say exactly like, have the same variable. 6x does not, 2y does. What am I doing with 2y? I'm subtracting it. So circle the term, circle the sign that goes with the term. Okay, plus 7, that's not like that. Neither is this, neither is that. So I have all of the terms that are alike with the y variable. My next term is 6y. That's the next one I'm going to circle. And what am I doing with it? I'm adding it, okay? So I'm going to circle the term, circle the sign that goes with the term. Then I'm going to keep going down the line. This is not like 6x, but this is. Circle the sign, circle the term that goes with the sign. Okay? So is this. Circle the sign, or circle the term, circle the sign that goes with the term. I still have one other term that is unlike the others. So I'm going to grab a different color. I'm going to grab blue, and I'm going to circle my very last term. It doesn't have anything else like it, but that's okay. So that was our first step. Now we have to rewrite the like terms together. Okay, well, let's start with 3y. We're just going to drop it down. So I have 3y, cross it out so we don't accidentally write it again. I have minus 2y. Do you see why it's so important to bring that symbol down? It tells us, yeah, it looks like a negative, but really it means to subtract. They kind of mean the same thing. Okay, now, oops, don't forget to cross that out. Let's bring down our blue terms, our green terms. Whew, sorry about that, friends. Plus 6x, cross it out. Now I have minus x and plus 4x. My recommendation is always put, when you're subtracting, put it last. So I'm actually going to put plus 4x first, but I can do that. Okay. Last, I'm going to put minus x. This will prevent me from having possible negative numbers if it comes up before I know how to handle negative numbers. My last term is plus 7. Please don't forget about that little plus 7 there. Okay, so that's step 2. Rewrite the like terms together. We're just rearranging. And now let's combine. So let's take a look at 3y minus 2y. If I have 3 y's, but I take away 2 of them, I'm left with 1 y, or just y. Okay, you can put a 1y in front of it, but remember, 1 is the multiplicative identity. Okay, if I multiply any number by 1, I just get that number. So that's why we leave it off. Okay. Let's look at our green numbers here. Okay, we have plus 6x plus 4x. So if I have 6x and 4x, I have 10x minus 1. X, okay, would be plus 9x. My last term is to add the 7. Okay, I know that seems like a lot, but you can do this. If you have any questions whatsoever, make sure you reach out to your teachers. Other than that, I hope you have a most fantastic rest of your day.